Hello everyone. Welcome to hydropower. Today we will be talking about the 1. Source of sediment. 2. Sediment yield in reservoir. 3. Sediment yield in river. So, let's start from the source of sediment. Sediment refers to particles of soil, sand, silt, and debris carried by water that can accumulate in reservoirs and affect system components. It can reduce storage capacity, clog intakes, wear on turbines, and impact downstream ecosystems. Sediment management involves plans, bypass systems, dredging, erosion control, and fish-friendly design to ensure efficient operation and environmental sustainability. Sediment in reservoirs comes from various natural and anthropogenic sources. Here are some sources of sediment in reservoirs. Erosion of watersheds. The primary natural source of sediment in reservoirs is the erosion of soil and sediment from the surrounding watersheds. Rainfall, runoff, and flowing water can erode soil particles from hillsides and land surfaces, carrying them into rivers and streams that feed into the reservoir. Riverbank and channel erosion. Rivers and streams that feed into a reservoir can contribute sediment due to erosion of their banks and channels. High water flow rates, particularly during storm events, can lead to increased sediment transport. Deforestation and land use changes. Human activities such as deforestation, urbanization, agriculture, and construction can accelerate soil erosion and sediment transport into reservoirs. Removal of vegetation reduces the natural protective cover of the soil, making it more susceptible to erosion. Mining and quarrying. Extractive industries, such as mining and quarrying, can disturb the land and expose sediment-bearing materials. Erosion from these activities can contribute to sedimentation in nearby water bodies, including reservoirs. Streambank and shoreline erosion. Erosion of streambanks, shorelines, and other sediment-rich areas along the reservoir's edge can release sediment directly into the water. Upstream erosion. Sediment eroded from upstream areas can be transported downstream by rivers and streams, eventually accumulating in the reservoir. Construction and dam operations. The construction of dams and associated infrastructure can introduce sediment into the reservoir during the construction phase. Additionally, dam operations, such as water releases and changes in flow patterns, can influence sediment movement. Agricultural runoff. Excessive use of fertilizers and poor land management practices can lead to increased soil erosion and sediment runoff from agricultural fields. Natural geological processes. Natural erosion and weathering of geological formations can release sediment into rivers and streams, contributing to sedimentation in reservoirs. Land disturbances. Natural events like wildfires, landslides, and earthquakes can disturb the landscape, leading to increased sediment transport into water bodies. Now let's talk about the sediment yield in reservoir. Sediment yield in a reservoir refers to the amount of soil, sand, silt, and other materials that are transported and deposited in the reservoir over a specific period, typically measured in terms of volume or mass. Sediment yield is an important factor to consider in the management of reservoirs, as it can affect the reservoir's storage capacity, water quality, and overall functionality. High sediment yield can lead to sedimentation, which is the process of sediment accumulating at the bottom of the reservoir over time. This sedimentation can have several impacts. Reduced storage capacity. Accumulated sediment reduces the space available for water storage in the reservoir, which can limit its ability to store water for various purposes, including hydropower, irrigation, and water supply. Decreased hydropower efficiency. Sediment can enter the intake structures and turbines, leading to abrasion, wear, and reduced efficiency of the hydropower generation equipment. Water quality. Sediment-laden water can affect water quality by increasing turbidity, reducing clarity, and potentially carrying pollutants. Maintenance costs. Sediment accumulation may necessitate periodic dredging or maintenance activities to remove the sediment, which can be costly and time-consuming.
Environmental impact. Sedimentation can alter downstream ecosystems by changing the physical characteristics of rivers and streams, affecting aquatic habitats, and potentially harming aquatic life. Managing sediment yield in reservoirs involves various strategies, such as implementing erosion control measures in upstream areas, designing sediment bypass systems, optimizing reservoir operation to minimize sediment accumulation, and conducting regular monitoring to assess sediment levels and plan maintenance activities. Effective sediment management is essential for maintaining the functionality and longevity of reservoirs and the benefits they provide. Now we go for the sediment yield in river. Sediment yield in rivers refers to the amount of soil, sand, silt, and other materials that are eroded from the river's watershed and transported by flowing water. It is an important measure of the sediment load that a river carries downstream. Sediment yield is influenced by various natural and human factors, including climate, geology, vegetation, land use, and human activities. Here's a brief overview of sediment yield in rivers. Natural erosion. Natural processes such as weathering, erosion, and mass movement in the watershed contribute to sediment yield. Rainfall, snowmelt, and runoff dislodge soil particles from hillsides and riverbanks, transporting them downstream. Human activities. Human interventions like deforestation, construction, agriculture, and mining can accelerate erosion, increasing sediment yield. These activities disturb the land, removing protective vegetation cover, and altering the landscape. Monitoring and assessment. Sediment yield is often monitored to understand the health of river ecosystems, assess sediment-related risks, and guide management decisions. Sediment transport. Sediment yield is an indicator of the sediment load that rivers transport. Sediment can be carried in suspension in the water column or transported as bedload along the river bed. River dynamics. Sediment yield impacts river dynamics by influencing channel morphology, sediment deposition, and erosion patterns. Excessive sediment can lead to channel aggradation or degradation. Impacts of sediment. Sediment yield can affect water quality, aquatic habitats, navigation, and infrastructure. High sediment loads can increase water turbidity, smother aquatic habitats, and contribute to sedimentation in downstream water bodies. Sediment management. Managing sediment yield involves erosion control measures in the watershed, restoring riparian vegetation, implementing sustainable land use practices, and considering sediment transport in river management plans. Climate change. This can influence sediment yield by altering precipitation patterns, runoff rates, and erosion dynamics, potentially exacerbating sediment-related challenges. Balancing sediment yield is essential for maintaining river health, water quality, and the overall function of river systems. Effective sediment management strategies aim to reduce erosion, mitigate downstream impacts, and promote sustainable river ecosystem management. Thank you. See you in next video.